warfare, cyber warfare against physical infrastructure is absolutely feasible. Okay? Whoever did this showed that it can be done again. And by the way, there are far simpler attacks than attacking a nuclear enrichment facility. You can attack hydro and power, which are, by the way, not well secured. I guess it's a wake-up call. And the problem is it's very difficult to protect against this, because the reality is that Stuxnet bypassed everything we had. Not just our company, virtually every company that we know about. I mean, they were quite effective. And because ultimately the attackers can use our software and they can figure out exactly what will get past our software because they have the same software that our customers have. What is Stuxnet? So Stuxnet is a computer worm and Trojan horse, if you will. By worm, I mean it spreads on its own. That's what a computer worm means. So it spreads from computer to computer over a network. A Trojan horse means that it actually does something that's not supposed to do. It causes damage. And you might also call Stuxnet a virus, a parasitic virus in some ways, because it actually attaches itself and it embeds itself in other data files and software in order to cause itself to be spread by humans who might, for instance, take a thumb drive around. Okay, so it's actually a very complex beast. Now, to give you some perspective, the typical computer virus is about, or typical computer threat is about 10 kilobytes in size, 10,000 bytes. Stuxnet is 500 kilobytes, roughly 50 times the typical threat that we see. And it is not 50 times bigger because it has some images in it, because it has some graphics, which many programs have graphics that make them bigger. It is 50 times bigger due to logic, the logic that is used to, as we will see, attack the Iranian nuclear enrichment program. Okay, so it is something that, as you will see, we can't imagine that any organization other than a government organization could have constructed this. Well, there are really 4 distinct phases that Stuxnet goes through. It has to spread on its own, has to discover the proper computers. It doesn't want to take out the wrong computers, where it can disrupt the centrifuges, do disruption, all while evading detection. So it has to do each of these 4 things exceptionally well. Stuxnet uses 7 distinct mechanisms to spread to new computers. Okay? So to give you some perspective, we are surprised when a threat uses one mechanism to spread to new computers. Stuxnet used 7 different mechanisms. Okay? So if Stuxnet were to somehow find its way into a machine, for instance, maybe an insider introduced it to one of these machines on the research network. Maybe somebody had a thumb drive that they found outside on the street, and they plugged it into the computer, to see what was on it, and it introduced Stuxnet. Who knows? Okay. The point is, if it got into one of these computers, first of all, how does it spread? So it copies itself to open file shares. So many of you use networks, right, on campus here, and you share files on your hard drives. You copy files from drive to drive. Well, people do that as well potentially on the Iranian enrichment network here. And so Stuxnet will find open shares and automatically propagate to those computers on its own. Doesn't need any interaction. It attacks a hole in the Windows print spooler. So as it turns out, the computer there that's connected to that printer has software running, and that software can be attacked. Okay? And so Stuxnet will look for that software and attack it. And in fact, I believe it was a day 0 attack, if I'm not mistaken, that it used in order to spread to that computer that runs the printer software. Okay? It attacks a hole in what's called the Windows RPC service. So what it does is there's a service to allow 2 computers to talk to each other to perform commands. And that is not properly secured, and so it attacked that. Okay? It attacked the Siemens database software. So if you're not familiar, the Step 7 software here that I referred to, Step 7 software, is from Siemens. And this software is used to program industrial control systems like this PLC here. So you build software using Step 7, okay, and then you transfer that software onto the PLC to actually run the centrifuges. Okay, that's the way this works. Okay, so these computers, this Windows computer here runs a database, and the database is used to store telemetry from the centrifuges. In other words, what's happening, how fast are they spinning, have there been any errors, and so on. So that database software, as it turns out, had a default password that came from the manufacturer, from Siemens. Okay? In other words, you could log into the software using the name and password, so the administrator, when they first started, could get access to the system. Okay? You're supposed to disable the default name and password, but nobody ever does. Same thing with Oracle software. If you've heard of Oracle database, there's always a password and username Scott and Tiger for that. And everybody knows about it. It's disabled. But lots of people don't disable this. So it actually cracked in using the name and password default from the factory to break into the database software and then introduce itself onto the computer from there, drop itself onto the computer and infect the computer. In addition, it infects what are called Siemens PLC data files. So again, the Siemens software on this machine, the Step 7 software, has data files that are actually used to contain all of your logic for the PLC. Okay, it's like a Word document, if you will, but instead it holds commands to control the controllers here. And by the way, these controllers don't just control centrifuges. These can be used to spin cotton candy. They can be used for roller coasters, all kinds of different things. Right? So Stuxnet will actually copy itself and embed itself, this is the viral aspect of itself, into a data file. So if I copy a data file to your computer on a thumb drive, that data file will then spread the threat as well. And the threat will be auto-launched when you load up that data file in the program. It's like loading a file into Word for Windows and having the threat run without your knowledge the moment you load it. Okay, so it'll spread that way as well. And in addition, it has a peer-to-peer updating mechanism. So if just one of the Stuxnet threats on a network can get to the internet and connect to a command and control server to update itself, to download a new update. So for instance, this version, let's say, imagine this version is the only computer that can get to the internet because the rest of the computers are limited. It will then update itself on the network, even if the network's entirely disconnected once it gets on there. This is not unprecedented, but the combination of these that we've seen so far is unprecedented. And so here's my question, and this is going to be obvious to many of you. If this computer that is the one that they really want to get to is air-gapped, okay? In other words, you have to take the sneaker net to get there, how did they get onto that computer? And the answer, we believe, is one of two different ways. The first way is USB drives. So these thumb drives that you walk around with and you stick in your computer. If someone were to, for instance, take this, just stick it in a computer. That's all you need to do, just stick it in a computer, and then walk through the air gap past the soldiers. You're a legitimate scientist. You're not a spy. You will then introduce Stuxnet onto that computer there. The other possibility is, again, this printer could have been shared between the networks. Stuxnet could break into the printer computer and from there spread to this network if, in fact, that was the case. We don't know if that's the case or not. Okay? Or it could have been an insider who actually just walked it in. We don't know. 6 of the flaws that were targeted by Stuxnet to spread or elevate control, in other words, to gain control of the system, and not just a low-level user account, but to gain complete control of the system, were unknown to software vendors and security vendors. Stuxnet spreads on its own, as we've seen, until it discovers the proper computers. If you do the math, Stuxnet verifies that the PLC, okay, the programmable logic controller, is controlling at least 155 total frequency converters. Okay? And as we learned, Iran's uranium enrichment cascade just happens to use roughly 160 centrifuges. So this is looking for exactly the fingerprint of the Iranian enrichment, at least from Natanz that we know. Stuxnet has now discovered the proper computer, which is connected to all of the hardware we talked about. Okay? What next? Well, it gets down to business. So here we have Stuxnet running on the Step 7 computer. Okay? And the first thing that Stuxnet does is it downloads a set of malicious logic to the PLC. Now this small event right here is groundbreaking because, as far as I know, and somebody can correct me, we have never had a threat that works on both a traditional PC and a programmable logic controller before. And remember, these are two separate computer systems. They speak different machine languages, different operating systems. They are totally different systems. So whoever launched this attack not only built a threat that could spread on Windows computers, but also understood the intricacies of the PLC, which is an entirely different microprocessor. Everything's different about it. So next, Stuxnet, it doesn't get right to business. It doesn't just start tearing things down. They're very, very careful. It measures the operating speed of the frequency converters here, for 13 days. Okay? So it sits very, very patient. It measures the speed of these systems. So as these systems are sending back telemetry, it's measuring that telemetry to see how fast are these centrifuges running. Okay? It's measuring over time, measuring that information for 13 days. And it makes sure that these motors are running at between 800 hertz and 1200 hertz, in that ballpark. Okay? Now, this happens to coincidentally be the frequency range required to spin centrifuges. In fact, frequency converters above 1,000 hertz are export controlled by the United States. In other words, these are considered bad things. They're only used for enrichment, as I understand it. Okay? So it's looking for this signature of this speed of running. In other words, not only is it enough for all the hardware to be there, but these have to be spinning at the right rate for 13 days. Once Stuxnet is sure that it's on a PLC that is controlling centrifuges, it then begins its mischief. What Stuxnet does is it raises the spin rate of the centrifuges to 1410 hertz, or at least tries to, and it does so for just 15 minutes. It doesn't do it for hours and hours and days. It does it for 15 minutes before it sends it back to normal. Okay? So the logic running on here, which by the way is integrated directly into the logic that was previously running on this PLC. In other words, whoever wrote Stuxnet understood exactly what the existing Iranian control logic was here and integrated with it perfectly. They didn't just replace it wholesale. They integrated it and complemented it. So it spins them up, and then it goes back. After 15 minutes, they go back to normal. Okay? So imagine if somebody, the nuclear scientist is in the room, and he's taking a coffee break, and everything starts, whirring much faster, and he goes back, and everything's fine. Huh? What just happened? So then Stuxnet, very, very patient, sleeps 27 days. Does nothing for 27 days. Okay? And then, ready for this? Stuxnet then slows the spin rate to 2 hertz. So it goes and takes it down, okay, to 2 hertz for 50 minutes. Okay? Now, we'll talk about why you would raise it and why you would lower it and so on, but it's interesting. And then you know what it does? After 50 minutes, 27 more days, and it goes and repeats the process. So what about Iranian fail-safe systems? I mean, presumably, they are monitoring these centrifuges to see if they're spinning within the proper rates. Are they spinning between 800 and 1,000 hertz, okay, 1,100 hertz? And surely alarm bells must have been blaring at the enrichment plant, okay? I mean, obviously. So is it possible that Stuxnet pulled a mission impossible? In other words, put a photograph in front of the video camera so that, as the bad guys are doing the mischief, they don't get seen because it looks like the hallway is empty? But in fact, exactly what Stuxnet did. When Stuxnet gets down to business, what it does is it sends this recorded data back to the monitoring systems while it is in fact sending the centrifuges to spin at 1,380 hertz or 2 hertz. So what about the big red button? There's always a big red button, right? At least in all the movies there's a big red button, and we believe there were big red buttons in the Iranian enrichment plant as well, so you could hit the button and shut everything down if something really bad happened, okay? Well, as it turned out, Stuxnet dealt with that too, and what it did was, in the software, it actually changed the logic so that even if you hit that big red button, it would do nothing during this period of time. In other words, while it would not slow things down, it would just keep them going. Now, I have to use a word like unbelievable. I mean, come on, it's pretty, look, there's no science fiction here. Everything that has been done here is less a feat of engineering and more a feat of espionage and coordination and getting 50 different things right where any one of them could fail. I mean, think about all the things that could fail here. They got all this right, at least from what we can tell. Stuxnet inhibits different behaviors in the presence of different security products to evade detection. So what it does is, once it arrives in a computer system, it assumes it's going to be running with antivirus software. It assumes it's going to get past that antivirus software, probably at least initially. But what it doesn't want to do is raise any triggers. In other words, it doesn't want to do something that's so suspicious that the antivirus software stops it. Stuxnet's authors digitally signed Stuxnet with stolen digital certificates. Now, what is a digital certificate and what does this mean? As it turns out, there is something like a certificate of authenticity in the computer world. We accomplish this with cryptography. Okay? We use what's called public key encryption in order to do a certification of software. Okay? And typically, a software publisher like Microsoft or Symantec or Google, when they release new software, they will effectively do a cryptographic certificate of authenticity for the software they release, which prevents any tampering with that software. So what did the authors of Stuxnet do? Well, they somehow penetrated 2 corporations and stole their encryption keys that are used to do this certificate of authenticity. The point is that stealing these encryption keys that would be used to create this certificate of authenticity and make it look like Stuxnet came from Realtek Corporation, based in Taiwan, as opposed to from wherever it came from, is unheard of. It has never happened before that I know of. Maybe it's happened in cases I haven't heard of. We do know about subcontractors that were known to be working with the Iranians on nuclear enrichment that were infected first. These companies, unknowingly, potentially, ferry the infection to their research and enrichment networks. That's what we believe. And the Institute for Science and International Security writes, it's increasingly accepted that in late 2009 or early 2010, Stuxnet destroyed about 1,000 IR-1 centrifuges of about 9,000 deployed at the site. The engineers who looked at this were floored by its complexity. The attacks that it used could only have been gleaned by looking at the source code of the Windows operating system or reverse engineering Windows, which would take, if you didn't look at the source code for Windows to find the attacks, the day 0 attacks, in other words, the unknown attacks that were used, it would require months and months and months, maybe years, to identify these flaws within the operating system and then exploit them. Here, these are sort of custom attacks for vulnerabilities in systems we didn't know existed. The logic is also quite impressive. The presence of the digital certificates is unprecedented. So there are absolutely indications based on the code. So why is this important to you? I mean, I told you an interesting story. It's fascinating that somebody could actually go to these lengths. And again, there's no technology here that is fundamentally new. Everything that was done here can be done by smart people using existing technologies. This is no Watson that's playing on Jeopardy. There's nothing no fundamental computer science here that's different. However, again, to get these 50 different things all to work just right so that this could work is unprecedented.
What's your biggest fear?
So my biggest fear is that some way the attackers figure out how to mass disseminate a threat to hundreds of millions of computers. In other words, typical viruses, worms tend to spread to thousands, tens of thousands of computers, and it often takes a long period of time. If somehow attackers could distribute a payload to hundreds of millions of computers in a very short period of time, and then cause that payload to damage those devices in such a way that it's not just about fixing the software, but they actually hurt the hardware, which is possible in many computers, you could have an infrastructural outage that would take months to repair, because you'd have to literally get new hardware, have people, technicians go from computer to computer.
For more, please visit us at stanford.edu.